Let's talk about something that's often overlooked in day-to-day life, but is super important in the world of video games, and that is finding the remainder after division. Here we are playing some Hearthstone, where we've already won a coin toss at the start of the game, and we're now dealing some random damage to multiple minions on the board before our turn timer runs out. The question is, how can any of these decisions relate to division and remainders? First up, let's explain what a remainder is. Whenever we divide two numbers, then there's a good chance that they won't divide perfectly, and there'll be some amount left over. If we take our 5 here, we can try and fit these into two equally sized groups. But we'll end up with this one left over at the end here. And this is the same as saying that 5 divided by 2 is going to be 2 with a remainder of 1. And if we do this with any whole integer, then we'll always end up with either this remainder of 1 at the end, or they'll be perfectly divisible and fit into our two equal sized categories. And this is pretty much the very definition of even numbers and odd numbers. And we can use this idea of remainders to help us make decisions in our games. Let's say we wanted to randomly decide which player was going to go first in our game, and we're going to simulate that with a coin toss. So first up, we want to generate some random number, and we're going to divide that by 2 and then check what the remainder is. If that remainder happens to be 0, it means that it's an even number, and that means that we could display heads on our coin and say that player 1 is going to go first. Or if this remainder is 1, then it means that the number is odd. So we could then display tails to our player and say that player 2 is going to go first. So this is just one example with 2 players using even and odd numbers, but we can do this with any division. So rather than just dividing by 2, let's try dividing by 4 instead. And to help visualize this, let's look at it around a circle. So what we're going to do is we're going to split this circle into 4 unique steps. We're going to start over here at 0, and then every time we move up our number line, we're just going to add the next number in. And these are going to represent the remainders after our division, because when we get to 4, well, 4 divided by 4 is going to be 1. So there is no remainder here, which is indicated by our 0. If we move up, we then have 5 divided by 4 is going to be once around our circle with 1 left over. The same with 6, we're going to go once around our circle and then take 2 extra steps. And then we've got a remainder of 3. And then we're back to a remainder of 0, because 8 divided by 4 is going to equal 2. So again, it goes in perfectly and there is no remainder. And you can actually extend this kind of logic of going around a circle to any number that you like. If we extended it to, say, 60 steps around our circle, we have a traditional clock, where the seconds are really just the remainders after a division. And every time we complete a lap around our circle, we're just going to add 1 minute onto our time, and then if we go around some amount more, then we just have a remainder in seconds. And we can very easily link these two ideas of turn timers and player turns. But before we do that, let's look at some of the maths that goes along with this. Let's say that our game has a turn timer of 30 seconds. We're going to have 2 players. And we're going to say that for this, player 1 has already been chosen to go first. And now we're going to say that our game has been running for 84 seconds. And we could query our game engine to check how long our level has been running. So first up, let's find out which turn we are into the game. We could say that 84 divided by our turn timer of 30. Well, if we run that through our calculator, we'll get 2.8. So we can say that 30 goes into 84 twice with some amount left over. So let's work out what that some amount is as a remainder. Well, first up, we're not interested in the 2 anymore, so we're just going to subtract that from our equation to leave us with 0.8. And now we can multiply this 0.8 by our divider of 30, and that will give us 24. So what we're saying is this 2 actually represents the 3rd turn in the game, because this starts at 0. And we can also say that we're 24 seconds into this turn. So the player has 30 minus 24 seconds left in their turn, so they have 6 seconds left to act. We can also take this one step further because we know player 1 started and we know that the turn number is odd, so it must be player 1's turn again. So we can get a lot of information out of just a little bit of math and a couple of variables that we stored up the top. But how might we do this in code? Well, it's actually pretty simple because we have something called the remainder operator, and that looks kind of like the percentage sign that you might be used to, although it doesn't serve the same purpose in this case. And when we use it in code, we use it exactly like the other arithmetic operators. So we've got plus, minus, multiply, and divide. So for this example here, we could say that 84 remainder 30 would give us 24, because it does all of this calculation and just spits out this end number here. And likewise, if we had some other calculation, say, let's keep it simple and say 5 remainder 5, well, because this is perfectly divisible, 5 goes into 5 exactly once, then this would return a remainder of 0. And as one final example, if we had something like 5 remainder 10, so this second number is bigger than our first number, all this is going to do is return our first number, so this would return 5. And the reason for this, if you remember back to our circle, it's like going around part of the way. So we haven't made a complete revolution and we've still got this 5 left over. And if you wanted to put some logic behind these equations, let's take how we would find our starting player. We might say that if some random number which we could generate through our code, remainder 2 equals 0, then make our first player player 1. We could then add an else block in here as well to make it player 2 if this returns 1. So hopefully this illustrates some of the power behind using random numbers and finding the remainder after division to make decisions in our game. But now I think it's time for a challenge. Okay, it's challenge time. Let's imagine that we have a 4-player game and we want to work out which player should go first. So we're going to assign a remainder to each player, so 0, 1, 2 and 3. And then we're going to generate a random number, say 63. And then we're going to find the remainder after dividing it by 4. And this remainder will tell us who will go first. So if the remainder is 0, then it will be player 1. A remainder of 1 will be player 2 and so on. As an extra challenge, try working this out both with your calculator and in code. And once you've got your answer, pop it in the community forum. And as a bit of extra fun, try and also solve the number left for you by the previous poster. And then, once you've solved that one as well, set a new number for the next person in the chain. If the chain gets broken, then just pick any random number to try and get it going again. So that's all for this one, and I'll see you in the next lecture.